Right, gentlemen, final 4 questions. Cumulative frequency, hopefully everyone knows that the cumulative frequency is just the running total, so less than 25 is obviously 0 because they start at 25 to 30. Then there's 12 people in the first category, or 12 fish, so the number that's less than 30 is 12. There's 31 in the next category, which means that less than 35 is 30 to 35 and 25 to 30 added together. And then as you go along, it's the running total. So less than 40 is going to be the sum of these 3. So you just add the 45 onto the last total and you get 88. Add 26 onto that 114 and add 6 onto that 120. So it's just the running total. You plot the points at the end of the interval because cumulative frequency is how many people have got up to that value. So if 12 people in the 25 to 30 category, then we say that the 12th person, or fish in this case, has a value of 30. So you plot 12 and 30, and that's that point there. And so on. So you plot at the end of 25 to 30, at the end of 30 to 35, and then you join them up with a smooth curve. You are allowed to join them with a ruler, and if you find this curve difficult, just do the dashes first and then join it through. For the median, very important you get this right. The median is the halfway value, which means halfway up the y-axis. And don't read it by the y-axis because they like to do a trick where they make the y-axis go further than where it stops. It's where the last point is. The last point's at 120. If they carried this on to 140 and 160, it wouldn't make any difference to where the last point was. So half of where the 120th value is the 60th value. You go across and down at 60, and you should get 37. They'll give you a little bit of tolerance, but only a little bit. Interquartile range, again, if that's the halfway point, then the quarterway point is half of that. So if halfway is 60, a quarterway is 30, across and down you get 33. And then the 3/4 way, that's the lower quartile, that's the median. The upper quartile is the 3/4 of the way to 120, which is 90. So at the 3/4 way, you go across and down, you get 40.5, or thereabouts. And the interquartile range is the difference between the upper quartile and the lower quartile, so 40.5 minus 33, which is 7.5. For the number of fish which are more than 43, you go up at 43 and across, and you'll find it should be a cumulative frequency of 108. Some people got 104. I think technically you're allowed to square out, so that should have been allowed. It does say half a square here. Maybe it's only half a square. Anyway, do be careful with these. It's going to be 108 or 104 depending where you got, and then that's the number of people that got less than 43. So the number of people who got more than 43 is whatever's left over. There are 120 to start with, so 120 take away 108 is 12. Okay, you've got 2 models of Houses of Parliament. First model, House of Parliament. Second model, slightly bigger. One's 25 high, the other's 20 high. So when it talks about the perimeter of the base, this is quite a hard question to understand what it's asking for. It's basically saying the base does this, wiggly, 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 and then the Gary's one, which is the big one, is 80, so how do we work out what the perimeter of the smaller one is? I think it's slightly tricky because you've never been asked a question like this before and you can't really visualize what it looks like. But perimeter is essentially a measurement of length. So when we're talking about measurements of length, it's just the scale factor. So to get from 20 to 25, you divide 20 by 25, and that's 1.25. So to go back, you divide by that, or multiply by 20 over 25. It's the same deal. This is just how I thought of it. So you get 64. Then it asks for the volume. And to work out relative volumes, it's all about the volume factor. So if the scale factor is 25 over 20, or 1.25, then the volume factor is that cubed. So you take 640 that the smaller one is, and you multiply it by the volume factor, not the scale factor, which is why you do 640 times 1.25 cubed, and that's why you end up with 1250. Then it gets even weirder. It talks about a new cathedral now, and it talks about their surface area ratio. Now remember, the surface area ratio is the scale factor squared. So if the surface area ratio is 9 to 1, that's the area factor, then the scale factor is the square root of that, which is 3 to 1. And the volume factor is the cube of that, which is 3 cubed is 27 to 1. So the larger model is 27 times bigger than the smaller one. They've given you the larger model, which means you need to divide that by 27. It's 1620 divided by 27, or as they've done it, times a third cube. But yeah, they've given you the area factor, so you get the scale factor by square rooting and then get the volume factor by cubing that. Quite tricky. And they're going to do more of the same here. First one, the volume of a cone is a third pi r squared h. So you just plug in a third pi r and h, and you get the answer. Should hopefully be fairly straightforward. It's just substitution. Slightly more tricky now. You've got a square-based pyramid. Sides are 6, height is 5. It wants to calculate the distance tm. Whenever you're calculating a distance in 3D trigonometry or whatever your lost words, 3D trigonometry. The key thing is what I call the shadow. It's the line directly under the line that's moving in 3D space. So Tm is the line that's moving vertically above the ground. The shadow is this line here. And that shadow is half the length of the square, so that's 3. And once you work that out, it's pretty obvious that Tm is just the hypotenuse of a Pythagoras triangle, 5 and 3. But yeah, it's almost invariably you need to work out the length of the shadow to work out whatever it is you have to work out about a 3D shape. And the shadow being the line directly underneath along the ground. The total surface area, there's 5 surfaces. They're the 4 triangles and then the base. The base is obviously 6 by 6, so that's 36. The triangles, slightly more tricky, but each triangle is actually, if we take a look at this face, is actually an isosceles triangle. That length you just worked out is the square root of 34, and the base is 6. You don't need to work out what the diagonals are, because if you know it's a triangle and you know the base and you know the height, then you can work out the area of a triangle. So it's just half base times height, half 6 times 34. And then there's 4 of them. 1, 2, 3, 4. Front, back, left, right. So 4 lots of those, and that's how you end up with 106. Tricky. Finally, the simultaneous equation. The key thing is when you've got a simultaneous equation that involves a quadratic, you take the linear one, that's the one that's not quadratic, doesn't have x squared, y squared, or xy or anything in it, and you take this one and you replace, in this case, y with this. So y equals 3x plus 4, you can replace y here with 3x plus 4, and it becomes x squared plus, instead of y squared, 3x plus 4 squared equals 34. 3x plus 4, when you square it, you do 3x plus 4 times 3x plus 4, it's not 9x squared plus 16, it's 9x squared plus 16 plus 3x times 4 plus another 3x times 4, so plus 12x plus 12x. And that simplifies to this, 9x squared plus 24x plus 16. Add the other x squared to get 10x squared. Bring the 34 over, 10x squared plus 24x minus 18 equals 0. Divide by 2. That's the only way you can simplify it, 5x squared plus 12x minus 9. And then factorize or use the formula, you get x is 3/5 or x is minus 3. Then you want to work out what y is. So the easiest thing to do is to plug it into the linear one, this one here. Y is 3 lots of x plus 4. So when x is 3/5, y is 3 lots of 3/5 plus 4, which is 29/5 or 5.8. And when x is minus 3, y is 3 lots of minus 3 plus 4, which is minus 5. Now, to get the final mark, you have to present your answers in pairs. When x is 3/5, y is 29/5, and when x is minus 3, y is minus 5. If you just give the x values and the y values separately, you haven't shown what the pairs are, because these values come in pairs of x and y. And that's it.